Hello and welcome to the fourth part of the VR character series. Today we will be adding procedural hand animations and a basic physics-based grabbing system. Let's start by setting up the new input actions. The first two are used for the grabbing input. Let's call them IA_grab left and IA_grab right. They have a value type of bool. We also want to create inputs for moving the individual fingers. Create left and right input variants for the thumb of type bool. The index and the rest of the fingers, which I call grip, are of type float. The middle to pinky finger is united as a grip input because my Oculus controller does not support individual finger tracking. Then, in the input mapping context, add the input mappings for grabbing when the grip button is pressed. We want to move the thumb when the player touches any of the top-facing buttons. The index and grip should be scaled by the axis of the trigger and grip buttons. Now go to the player character. I grouped the variables so it's a bit more organized. Create new variables for the right and left finger values called thumb value, index value, and grip value. Then call the input actions and set the values of the variables. The thumb input value is a bool, so you need to cast it to a float. Next, we need to create the individual finger poses. Go to the Control Rig, Characters, Mannequins, Rigs folder from the Mannequin Asset Pack and drag the CR Mannequin body into the level. Now the sequencer should open. In the sequencer, drag the red line all the way to the left to 0. Make sure that the sequencer auto-creates keys as soon as a value changes, or just create a key manually. Then select the green ball above the index finger and close the index as you like by rotating the ball. Make sure the space is local by checking if the icon in the top right is displaying a cue. If the index is in a position you like, go back to the sequencer, scroll all the way to the top and right-click the CR Mannequin body. Then select Bake Animation Sequence and store it in a new Fingers folder in the Animations folder. Then do the rest for the other fingers and the thumb. You only need to do this for the right hand because we can simply mirror the animation for the left. When you're done, you can delete the control rig and the level sequence actor and close the sequencer. Now go into the animation blueprint and create new float variables for each finger. Here we want individual variables for the middle, ring and pinky finger, unlike the grip variable we created in the character blueprint. We also need a bool variable for each finger collision. To set the finger collision check distance, create a new float variable called finger collision check distance and trace forward offset. Since we don't want the fingers to just snap to a close position, we also need a float variable called finger value interp speed. Otherwise, the fingers could get stuck in the object when closing the hand too fast. Next, we need to set up the finger collision detection. To do that, we need to create functions called check finger collisions, do collision check, set finger values, and check if finger can retract. Let's start with the do collision check function. Add an input value of type name called bone name and a bool called invert check direction. We need this variable for the left finger bones to invert the line traces. We create this function so we have all the logic in one place instead of copy-pasting it for every finger. Connect the bool input into a branch and connect a line trace by channel node to the true and false output pin. Also, add a bool output to the function called isColliding and input the return value of the line traces to it. This return value is true if the line trace collided with something. For the trace channel, you can leave it on visibility. Next, make some space and get the mesh from the VR character reference. From there, get the socket location and rotation from the bone name function input pin. From the rotation, get the right vector and multiply it by the finger collision check distance and the forward vector by the trace forward offset. Both variables have a default value of 2.0. From the socket location, add the scaled forward vector and input it into the start of the true line trace. Subtract the right vector from that same value and input it into the end input. For the false line trace, subtract the forward vector from the socket location and input it into the start input and add the right vector for the end. Next, go to the check finger collisions function and start by adding a sequence with 5 outputs. For every output, call the do collision check function and input the third finger bone. Here I start with the thumb, so I input the bone thumb_03_R. For the right hand, leave the invert check direction unticked and send the isRightThumb colliding variable to the output of the function. Do the same again, but this time for the left thumb, tick the invert check direction input and send the isLeftThumb colliding to the output. Now do the same for the rest of the fingers. Go back to the event graph, add 2 new outputs to the sequence in the event blueprint update animation function and call the check finger collisions and the set finger values functions. Next, open the check if finger can retract function. We need 3 inputs. First a bool called isColliding, then a float called previous value, which we pass by reference, and another float called current value. Start by checking if the isColliding input is true. If it is, add another branch checking if the current value is smaller than the previous one. From the previous value, get a node called sendByRefVar and connect it to the true output of the second branch and the false output of the first one. This node lets us send the value of the past reference. Next, load the previous value to the current value and input this into the sendByRefVar node. Input the finger value interrupt speed variable as the alpha input into the load node. Its default value is 0.25. A lower value means slower movement. We created this function to also save us from copy-pasting code. Next, open the setFingerValues function and add a sequence with 5 outputs. Let's start with the thumbs. Call the function check if finger can retract. Input the isRightThumb colliding, the right thumb value, and the right thumb value from the character reference into the function. The right thumb value from the animation blueprint is the one that should be passed by reference. Then do the same for the left thumb and the left and right index. For the middle, ring and pinky finger, we input the left and right grip value from the character reference as the current value, since the controllers that I am using don't support individual finger tracking. All we need to do now is to blend our finger animations. Before we can do that, we need to create a mirror data table for the many skeletal mesh to mirror our finger animations to the left fingers. In the Animation BP folder, right-click, go to Animation and select Mirror Data Table. Select the SK_mannequin skeleton, open the data table and check if the bones were assigned correctly. If you use a custom skeleton, just make sure the bones in the mirror name column are the mirrored equivalent bones of the name column. If you use the UE5 skeleton, these entries should be automatically set correctly. Back in the animation blueprint, add a new animation layer called Fingers with 1 input. Connect this layer between the component to local and the layer blend per bone node in the animation graph. In the fingers animation layer, get a layer blend per bone node and add a branch filter for the thumb_01_R bone. Connect the input pose to the base pose and the right thumb animation sequence to the blend pose 0 input. The blend weight is controlled by the right thumb value. Next, duplicate the layer blend per bone node. Change the branch filter to the thumb_01_L bone and mirror the right thumb animation sequence with a mirror node. Select the mirror data table we created and tick the mirror checkmark. For the left thumb, we want to use the left thumb value as the blend weight. Then do the same for the other fingers. You can also add comments by pressing C on your keyboard so you'll know which blend node blends what. This is it for the animation part. Now we can move on to implementing a simple grab system. For now, this system will only grab basic physics components, but we will expand it in the next video. Back in the VR character blueprint, create 3 new functions called Start Grabbing, Update Grabbing, and Stop Grabbing. In the Start Grabbing function, add a physics constraint component input which is passed by reference called physics constraint and a name input called bone2constraint2. Add a sphere trace by channel and input the world location of the physics constraint into the start and end location. Add a new variable called grab radius and set its default value to 5.0. Then input it as the sphere's radius. You can leave the trace channel on visibility. Next, break the out hint result and check if the hint component is valid. If it is, get the collision profile name of the hint component and check if it is equal to grabbable object. More to this later. If it's not, return null. The return value is of type actor and called grab actor. If the collision profile name matches, get the physics constraint reference and call the node set constraint components. The component 1 is the player's mesh and the bone name 1 is the bone2constraint2 input parameter. Set the hit component as the component 2 and the hit bone name as bone name 2. Then return the hit actor. That's it for the start grabbing function. Before we continue, let's add 2 new physics constraint components to our character. Make them children of the mesh and set their attachment sockets to the left and right hand bone. Select the mesh and under the animation class, clear the AVP VR character animation blueprint class and recompile. Now it is easier to set the physics constraint component location. This is the location where your character will be holding a weapon. More about this in the next video. For the RPC, I chose an X offset of -7.0 and a Y offset of 3.0. Invert the values for the LPC. Also add a rotation offset of -180 degrees to the X and Z axis of the RPC. Don't change the rotation of the LPC. Also tick the disable collision checkbox on both physics constraints and lock all angular limits. After that, add the animation blueprint again. That's all for components. Go into the stop grabbing function and add a physics constraint component input value which is passed by reference and call brain constraint. Back in the event graph, call the IA grab right input event. For the triggered output, call update grabbing. For now this function does nothing. It will be used when we implement the climbing system in a future video. Call start grabbing when started and input the RPC and the bone name hand_R. Drag out the grabbed actor output pin and promote it to a new variable. Call that variable right grabbed actor and set it after the start grabbing function. When the event is complete, call the stop grabbing function, input the RPC into it and set the right grabbed actor variable to null. Then do the same for the left. Now all the logic is set up, so let's go to our scene and add a cube from the starter pack shape assets. Scale it down to 0.1. I'll change its material to gold so it's more visible. Enable simulate physics, simulation generates hint events, and generate overlap events. Go to the project settings and then to collision and add a new object channel called Grabbable object and set its default response to block. Then add a new collision preset and call it Grabbable object. Set its collision enabled to collision enabled query and physics and the object type to Grabbable object. Only ignore the pawn and the vehicle. Click on accept and set it as the cube's collision preset. We do this so the physics actor won't launch the player because otherwise the player's collision system will think he's hitting a wall and will try to adjust his location. We also need to change the 2 line traces in the check top function. Change them from line trace by channel to line trace by profile and select the pawn profile. Great, now the player won't be launched anymore. However, one problem persists, which is that we cannot stand on physics objects since our mesh simulates physics and would push a physics object away from us when we stand on it. This happens because the legs of our mesh don't simulate physics and would therefore push it away with infinite force. Even though our hands do simulate physics, they can still push big physics objects away. To fix this, select the mesh, go to its collision responses and set the physics body response to ignore. This way, it only interacts with grabbable objects, but not with physics objects we might want to stand on. I am aware that this means that the player can stick his hand through physics actors. However, it was the best I could come up with for now. If I ever find an improvement, then I will include it in the video. And now we are done. I hope this video was helpful to you. If it was, make sure to leave a like and subscribe. Let me know in the comments if you need any help, and I will see you next time. Bye!